Welcome back. Let's take a look here at lesson 3. We're going to interpret a fraction as division. Our directions tell us to fill in a chart. We're going to jump right into B here. So they give us the mixed number. They give us 1 whole and 2 fifths. So we know that our unit is fifths. Well, we need to change our whole into fifths. 1 whole is equal to how many fifths? We know that that's 5 fifths. So we're going to add our 5 fifths to our 2 fifths to work backwards and get our 7 fifths. So now we have 7 fifths. 7 fifths is the same thing as 7 divided by 5. So if we have 7 divided by 5, we know that we're going to have 7 items. I'm going to push pause and draw my 7 boxes. So here I have my 7 boxes. We have 1, 2, 3, 4, 5, 6, 7 boxes, or 7 rectangles in this case, and each rectangle is split into 1, 2, 3, 4, 5 pieces. So 7 times 5 is 35. That means I have 35 fifths, and if I divided it by 5, that means each person would get 1 for number 1, 2 for number 1, 3 for number 1, 4, 5, 6, 7. That first person would get 7 fifths, meaning that everybody, person number 2 would get 7 fifths. Same with person number 3. Person number 4 would get 7 fifths. And last but not least, person number 5 would get 7 fifths. So if we had 7 wholes like we do here, 1, 2, 3, 4, 5, 6, 7, and we divided each one into fifths, we would have 35 fifths. And if we divided the 35 fifths by 5 people, each person would get 7 fifths. So person number 1 has 7, person number 2 has 7 fifths, person number 3, and so on, all the way to person number 5. So now let's take a look at the standard algorithm. So we have 7 divided by 5. So we say, well, how many times does 5 go into 7? Or 7 divided by 5 is what? Well, we know it's going to be 1 is 5. 7 minus 5 is 2. We're going to say 2 what? And that's going to be 2 fifths. Remember, we're not writing remainder 2. We're writing it as a fractional unit. So that's our final answer. So now to check, 1 and 2 fifths times 5. 5 times 1 and 2 fifths is equal to 1 and 2 fifths plus 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 1 and 2 fifths. So we have 1, 2, 3, 4, 5 wholes, and we have 2 fifths, 4 fifths, 6 fifths, 8 fifths, 10 fifths. So we know that 10 fifths is equal to 2, so this here is equal to 7. So in C, they give us the division and standard algorithm. So I don't have to do anything other than rewrite this as a expression. I know it's 7 divided by 2. I know that if I had 7 wholes, let's just draw 7 quick circles here, and I divided each one in half, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 halves. So another thing that you can do to find that is simply multiply these two. I know that 7 times 2 is 14. That's how I get those 14 halves. So if I said 7 divided by 2 is 14 halves divided by 2, what I would do is just simply take this and say, well, it's going to be 7 halves. Because I know that if I had these 7 eggs and I said, well, you can have the top half, I'll take the bottom half, we each would have 7 halves. All right, our improper fraction is going to be simply we're writing our 7 over 2. We know that this fraction bar represents division. 7 divided by 2, 7 halves. Then we're going to write it as a mixed number. Well, how many halves can we pull out of 7 halves? Well, if I skip count it by 2, I would say 2, 4, 6. That would be 3. Then I would have 1 half remaining. And if you needed to see that, we can do that where we're writing our, if we take 2 away, Take 2 more halves away, 2 more halves, 1 half remaining. So we know that each one of these is equal to 1, and then we have 1 half remaining. So 7 halves is equal to 3 wholes and 1 half. Now let's take a look at our standard algorithm. Now we have 7 divided by 2. 7 divided by 2 is 3. 3 times 2 is 6. 6 taken away from 7, or 7 minus 6 is 1. We have 1 what remaining? 1 half. Looking at D. All right, so we have the same 7, but now instead of it being split in halves, it's split into fourths. So our same 7, and I'm just going to draw the letter T. And I know these fourths are not drawn to scale, but they would be all equal. So we have, if we skip count by fours, we have 4, 8, 12, 16, 20, 24, 28. Once again, 7 times 4 is 28. So we know that this is going to be 28, not halves this time, but fourths. 28 fourths divided by 4 is equal to what? So let's take a look and see. We know that in this case we have, if we split it by 4 people, the person that is, let's use different colors. So person number 1 is going to get the red piece. He gets 1, 2, 3, 4, 5, 6, 7. So it's going to be 7 fourths. And if we did continue, person that got the blue top right will get 1, 2, 3, 4, 5, 6, 7, and so forth with the bottom left and the bottom right. Each one of those people would both get 7 pieces. Let's just go ahead and finish it up. 1, 2, 3, 4, 5, 6, 7 fourths. And last but not least, 1, 2, 3, 4, 5, 6, 7. So no matter how you look at it, 7 divided by 4 is equal to 28 fourths divided by 4, and it will give you 7 fourths. All right, so now we're going to turn this improper fraction into a mixed number. We know that we can take 4 fourths, which is equal to 1 whole. That's 1 whole plus our remaining 3 fourths, and we would have 1 and 3 fourths. Let's do the standard algorithm. 7 divided by 4. 4 goes into 7 one time. If we try to put 2, it would be 8. We don't have 8. We only have 7. So it's going to be 1. 1 times 4 is 4. 7 minus 4 is 3. So we have 1 and 3. 3 what? 3 fourths. All right. We didn't check our last one. Let's go ahead and check these two. So we had, in this case, it was 2 times 3.5, which is equal to 3.5 plus 3.5. So 3 plus 3 is 6. 1 half plus 1 half is 2 halves, and that is equal to 1. So that's equal to 6 plus 1, which is equal to 7. Same thing with 1D. If we were to check, we would say 4 times 1 and 3 fourths is equal to 1 and 3 fourths plus 1 and 3 fourths plus 1 and 3 fourths plus 1 and 3 fourths. So we have 1, 2, 3, 4 wholes, and we have 3, 6, 9, 12 fourths. So I know that 4 fourths is equal to a whole, so 4 fourths would be 1 whole, 8 fourths would be 2 wholes, and 12 fourths would be 3 wholes. So this is equal to 3, and I know that 4 plus 3 equals 7. Let's go ahead and move on to number 2. Number 2, a coffee shop uses 4 liters of milk every day. If there are 15 liters of milk in the refrigerator, after how many days will more milk need to be purchased? Explain how you know. All right, so let's take a look at what they're asking us here. So let's draw this out. I'm going to make my 15 liters. All right, so I have my 15 liters of milk. If the coffee shop uses 4 liters of milk every day, that means after day 1, it'll use 4. Day 2, it'll use another 4. Day 3, it'll use another 4. Day 4, it won't have enough milk, so they'll have to buy more milk after 3 days. All right, so we can see that after 3 days, the coffee shop would need to buy more milk. Also, we could have said that, well, how long would 15 liters last? By doing simple division. 15 liters, if we're using 4 liters a day, well, 15 divided by 4, we know that that's 3. 3 times 4 is 12. 15 minus 12 is 3. It's going to be 3/4. It has 3, 1, 2, 3 out of the 4 that it needs per day. So that would be our answer. After 3 days, they're going to need to buy more milk. And the reason why is because they're only going to have 3 out of the 4 liters that they need. And that's where that 3/4 is right there. All right, let's check out B. If only half as much milk is used each day, after how many days will more milk need to be purchased? Let's take a look at that. So now, instead of using 4 liters per day, we're using half of that, which would be 2 liters per day. 15 divided by 2. 15 divided by 2 is going to be 7. 7 times 2 is 14. Do the subtraction, we would have 1 remaining, and that's going to be 1 out of 2. They'll need to purchase milk after 7 days. So after 7 days, they will need to purchase more milk because they're only going to have 1 out of 2 liters remaining that they would need. All right, moving on. Polly buys 14 cupcakes for a party. The baker puts them in the boxes that hold 4 cupcakes each. How many boxes will be needed for Polly to bring all of the cupcakes to the party? Explain how you know. So we're talking about a young lady that has 14 cupcakes, but there can only be 4 in each box. So we have 14 divided by 4. That's going to be 14 goes into 4 3 times. 3 times 4 is 12. Do the subtraction, we get 2. And we have a remainder 2. We know that if we only had 3 boxes, we would have 2 that were unboxed. So we would say that Polly will need 4 boxes, 3 of which will be full. So that will be 3 times 4 is 12. And then the last box only have 2 cupcakes in it. Okay, looking at part 3B here. If the baker completely fills as many boxes as possible, what fraction of the last box is empty? How many more cupcakes are needed to fill this box? Well, we know we had 3 and 2/4, so that means that 2/4 were empty. And 2/4 is equivalent to 1/2 of the box is empty. So 1/2 of the last box will be empty. And to fill that half, 2 out of the 4 were there, so we would need another 2/4, which is equal to 2 more cupcakes. 2 more cupcakes are needed to fill the last box. All right, so hopefully even before checking it, hopefully you got everything right, and we're on our way to lesson 4 and 5, and then we'll have our quiz on topic B. Let's make sure we continue to work hard, and I'll talk to you in the next video. Thank you.